Hello, grade 11. This is another application on Newton's second law with an applied force that makes an angle, okay, with the horizontal. So let's do this exercise together. First, a box of mass 10 kilograms. So this box has a mass of 10 kilograms. So first, let me put the given down. Mass 10 kilograms. Sliding to the right across a frictionless surface. Sliding to the right means this box is moving to the right in this direction, okay? Along the horizontal axis. By an applied force, this applied force has a magnitude of 40 Newton at an angle of 37 degrees above the horizontal. What does this mean? This applied force, okay, so there's a force exerted on this box that's trying to pull this box at this angle, 37 degree with the horizontal. This is the horizontal. And so this force, which is, let me call it F, makes 37 degree with the horizontal. What is the acceleration of the box? So we need to find A, the acceleration. What other thing we have? We have F has a magnitude of 40 Newton. And we have the gravitational acceleration, which is the G, which is equal to 10 meters per second square. Okay. How do we solve this problem? First, we have force, and we have to find acceleration. What is the law that relates both the force with the acceleration? Of course, Newton's second law. So we have to use Newton's second law, which is F naught, the sum of the external forces, is equal to what? Don't forget the vector here, is equal to mass times acceleration. Okay. Okay, now first step, we have to find the forces that are acting on the box, on our system. Okay, so let's first draw a diagram representing these forces. Let's take that this is the object, our object, and lying on a surface. What are the forces that are exerted on the object? First, we have the force, the applied force at an angle of 37. Okay, so this F, we represent it. Then we have it's sliding on a surface. The surface will exert a normal force. This normal force is directed down, upward, okay? And we have the weight of the object, which is directed vertically downward, okay? The point of application is the center of the point of application of the forces is the center of the object, the center of the box. This is the weight. I will represent it by Fg, which is the gravitational force. Okay. So, what are the forces acting on the system? We have, let's put on the left side before the equal sign, what we have the sum of the forces. So let's write, or let's put them down. Let's put the forces down, okay? So we have the normal force and plus, look, here the box is sliding on a frictionless surface. Frictionless, it means that this surface does not exert any friction force, okay? So it's frictionless, it means there's no friction, okay? Pay attention to such keywords. N plus Fg, okay, plus big F, which is the applied force at an angle, equal to A. Okay. The next step here, we have to get the components of the forces. We should remove the vectors and put instead the components or the directions of each vector, okay? So let's look. N and Fg, the normal force and the weight force, are along which axis? They are along the y-axis, right? If this is the y-axis, okay? So this is the y, okay? This upward direction, we will take it as a positive y. And here, along this axis, this is the horizontal axis, we call it x-axis, okay? And to the right, we have positive x. So the n is along the y direction. So what is the direction for n? It's positive, right? So we put positive n, and here we remove the vectors because we are putting the direction now of the vector, okay? Positive n, y. Y represent the direction or the line of action of the force, which is along the vertical, okay? Fg, which is it's pointing downwards, okay? So the weight is pointing downwards along the y axis. So, and downward means it is a negative. Why is that? Because we chose the upper direction to be positive, okay? So it's negative Fg. And we will put y to note that this is along the y-axis, okay? Now, look at this force F. Let me draw it here. F is neither in the x, neither in the y, it's in the plane x and y. It's in the plane x and y. It has components both in x and in y. So in this case, we have to get these components of f, okay? We have to get the components of f. Let me show you how. There's a video in the playlist. If you go to grade 11 playlist, you will find a video for the vector components of a vector, okay? I made a video on this subject. But let me show you. If we need the component, the fx component or the component of f along the x-axis, we project a line perpendicular to the x-axis. Okay, and this part here, this part, okay, did you see it? This is the fx. Okay, this is the component of f along x. And this here, this part here, did you see it? This is the fy component. Why? Because it's parallel to the y-axis, okay? So this is the part of f in the y direction, okay? So f, now يعني فككنا هيدا الفورس، فككناه ل two parts. part كان بالf x و part بالf y, okay? هلا how can we find these two components? By using cosine theta and sine theta. I also covered these in the first video in the playlist. You can go and check them, okay? So cosine theta is the adjacent over hypotenuse. Adjacent side means it's the side next to the angle, which is fx. This is the angle we are talking about, which is theta, which is 37 degree. Adjacent, it's the fx over f. The hypotenuse is it's the side facing the 90. This is the side, okay, and this is f, so it's f. So if you want to find fx is what? Fx is f cosine theta, okay? F times cosine theta. Now, if I want, this is fx. If I want fy, I do the same thing by using the sine theta rule. Sine theta rule, it's the opposite side, it's equal to the opposite side over the hypotenuse. And also you can find it in the video, okay? In the video I talked about, I told you about, I mean. So sine theta, it's opposite over hypotenuse. So Fy is F sine theta, okay? Fy is F sine theta. Now we have the components, okay, of F. Okay, let's write them down. If this is F, okay, this one here, it's Fx, okay, and this one here, it's Fy pointing upwards. Now we will continue. Instead of writing F, we will write Fy and Fx. Fy, it's pointing in one direction. It's pointing in the upward direction, okay, along the y, right? So we will write it as minus or plus, I'm sorry, plus, because it's pointing along the positive y-axis, okay? Plus, let me change the color, plus Fy, okay? And the fx, it's along the positive x-axis, so plus also fx, okay? A. Okay, now let's read again the question. A box is sliding to the right, so this box is moving along the horizontal axis. It's moving along this line, okay, the x-axis. It's not moving along the y, so there's no acceleration, okay? The speed of this object is not changing along the y-axis, okay? So there's no change in speed, and it remains at rest in the along the y direction. This means what? This means that the net, as we spoke in the last video also, the net force, okay, along the y direction is equal to what? There's no acceleration along the y, so what should we put? It's equal to 0, okay? It's not moving along the y direction, so there's no acceleration along the y, so it's equal to 0. So the forces that are acting along the y are all equal to 0. What are the forces that we have that are along the y direction? We have the normal force, yes, without a vector. What else? We have minus Fg, okay? And we have minus Fy, or plus Fy, I'm sorry, plus Fy, okay? These forces add up to give us 0. So, okay, so the sum of these forces are equal to 0. Okay, so what are we left with? We are left with A equal fx over m, right? And fx is what? Fx, it's equal f cosine theta, okay? It's equal to f cosine theta over the mass, which is 10 kilograms. Okay, let me now substitute their values. F, it's the force is equal to 40 Newton. So A, 40 times cosine theta, theta is 37 degrees, cosine 37 degree over 10. Okay, let me give you the answer right now. Over 10, it's 4 times cosine 30. Cosine 30 is 37, sorry. 0.79 times 4, it's equal to 3.19. So 3a, the acceleration, is equal to 3.19 meter per second square. So we got now the acceleration. Okay, hope this video was helpful. Thank you for watching.